Hello friends, this is Electricity and Magnetism paper solution part 7 of Guwahati University. So this is of second semester 2022. So this is part 7 and link of the previous parts are given in the description box. Before we start, please subscribe the channel if you are new to my channel, and also hit the bell icon and thumbs up button as well, and share with your friends and inspire me to create new contents for you. So now let's start. So this is question number 4e. This is question number 4e, right? So this is the questions. Here we need to state Thevenin theorem, Norton theorem, right? And also we need to find the Thevenin's and Norton's equivalent circuits with respect to the terminal C and D. With respect to these two terminals, here you can see C and D in this network. Also find the resistance to connect between C and D to dissipate maximum power, right? So this is the statement of Thevenin's theorem. I'm not going to explain word by word because here my motive is to give you the solution of the answer, a solution of the question. Okay, so I have created separately where I have explained the topics of electricity and magnetism, right? I have created content separately, so you may you can check in my channel. You may go to playlist, and you will get there a playlist with the name electricity and magnetism. Okay, so I have just started, maybe 3 and 4 videos I have uploaded, maybe 6 I think, right? So when I will get this topic, then I will explain there it's and everything. Okay, so please watch those videos as well, right? So this is the statement of Norton's theorem, and this is the statement of the Thevenin's theorem. So let me explain how to solve this problem related to this circuit. Okay, so here you see this is our given circuit. So first let us find the Norton's equivalent circuit of this network. So how to do that? In order to do that, I have considered two loops here. This is the first loop, this is the loop 1, and this is the loop 2, as I have mentioned here, right? So these are the direction of current I have assumed. Then I have applied here KVL. I hope that you know how to apply KVL. So I have applied KVL in both 1, 2 loop, first and second loop, right? So here you see, let me explain how I have applied. It's very simple. Just here you see we have here 10 volt. This is 10 volt, right? So direction of current is in this direction, right? So here you see this is the negative terminal, this is the positive terminal. It is going from the negative to positive. If the direction of current that you have considered in loop is going from negative to positive in a battery, then this should be kept positive, right? And then next what we need to do here, you can see that first add all the three resistance here. 10 plus 6 plus 2, that is equal to 18. Current is, we have considered I1, so 18 into I1. Then the resistance which are shared by the other loop, also shared with the loop 2, add these two also, 10 ohm plus 6 ohm, 16 ohm, and current in this loop is I2, that's why plus 16 I2, right? So adding these three resistance, 10, 6 and 2, all the three resistance if you add in this loop 1, then you will get 18 into I, right? That is given in negative, but the loop shared with the other loop, the resistance shared with the other loop, that is the loop 2, here current is following I2, right? And that should be written in opposite sign. I have gave it positive here, and this is equation number 1. Similarly, I have applied KVL in loop 2 as well, and so we have got here equation number 2, and solving these two equations I have got here I1 and I2 current, right? So hope you know how to solve these equations, right? So now you see, let's go to next slide. So as here you can see that I current is greater than I2 current, right? So I is greater than I2, and let me, here you see net current through this resistance of 10 ohm, this 10 ohm resistance, 10 ohm resistance. This is the direction of I1 and this is the direction of I2. I1 is greater, so I1 is 1 ampere, then I2 is in opposite direction 0.5 ampere. So net current will be directed in this direction, which is 0.5 ampere. 1 ampere minus 0.5 ampere is 0.5 ampere. So we can consider this one is positive, this one is negative, right? Current flows from positive to negative. So 5 ampere current, and there is resistance 10 ohm, 5 into 10 ampere, that is 5 volt, right? So I have replaced this resistance with this battery, right? So similarly, through this resistance, here you see 12 ohm resistance, current I have considered I2 in this direction, right? So in this through this resistance, here I2 current is flowing in this direction only. So I will take this as positive, this is negative, and I will replace this by here it was 12 ohm, right? 12 ohm, and I2 is 0.5 ampere, so 12 into 0.5, that is 6 volt, right? And here we will get VTH, right? So from this circuit we can calculate VTH, right? So apply again KVL, and VTH is 1 volt. So we have got VTH, right? So now make the voltage source short circuit, right? This is the rules of Thevenin's theorem, right? This is the rule of Thevenin's theorem, right? Now let me go to the next slide. Here you see, so I have made here this is short circuit, voltage source is replaced by the short it is made short circuit, right? Then you see this circuit now can be simplified as this, right? This resistance can be placed here, right? So doing so, we have got this network. So C can be drawn outside, right? And D, terminal D can be drawn outside like this. Okay, so hope you have understood this. Now you see, here we need to find the equivalent resistance, right? Then we will get RTH. So here you see, so for that let us make it star connection. I made star connection like this. Here you can see, then I have give here name R1, this is R2, and this is R3, right? So now you see, first take this part, then here add all the three resistance here, that is I have given D, okay, 10 ohm plus 2 ohm plus 6 ohm, that is 18 ohm. Then let's find R1. How to find R1? R1 will be equal to here you see this R1 is between 6 and 10, so here you have got 6 into 10 divided by D, that is 18, right? So divided by 18, then calculating this we have got, so why I have taken here 10 and 16 as 10 and 6, because here you see this R1 resistance is between 10 and 6 ohm resistance. So hope you have understood this. So then I have got here 3.33. Then similarly we can find R3 and R2 as well, right? So these are the 3 resistance. Then let me go to the next slide. So here you see, after getting R1, R2 and R3, I can convert this network in this form, right? So as I have already got R1, R2 and R3, so it will take this form. Now it is simplified, right? So here you see, these two and these two are in parallel, and this parallel combination with this in series, right? So first, so these two are series, right? So R2 plus 12, we have got this, and R3 plus 4 ohm, we have got this, right? So now combination is seems to be like this. Then from here, let us calculate the resistance in parallel combination. Then this parallel combination is in series with this R1, right? Then calculating the equivalent resistance in this circuit, I have got RTS. This is the RTS. So we have got RTS and we have also got VTS. Here you can see we have got VTS. Now we can draw the Thevenin's equivalent circuit. So this is the Thevenin's equivalent circuit. Now here one more question is asked. So what resistance should be inserted here between these two to get maximum power, to obtain maximum power? That will be that maximum resistance must be equal to RL, RTS and RL, and that load resistance must be this one to obtain the maximum power. Okay. So now let me find the let me show you how to get the Norton's theorem. So here you see, again I have applied here you see, so in order to calculate in order to find the Norton's theorem, here you can see this between C and D, I need to find IN, Norton current, or you can say short circuit current. So between C and D, right? So now we have got 3 loops. This is third loop, this is second loop, this is the first loop. 3 loops we have got, and in all the 3 loops I have applied KVL to get these 3 equations. How to apply KVL already I have shown once, right? And solving these 3 equations, I have got I1, I2, I3. Hope you know how to solve these 3 equations. Then I have got IN is equal to this, right? IN is equal to this. So IN will be equal to I2 and I3. Why? So let me show you here. You can see, if you see this diagram, so here you can see, this is the direction of IN, right? So here you see, direction of I2 is in this direction and direction of I3 is in this direction. This is I2, this is I3, right? So because I have taken in this direction, right? And this one is in this direction, I have taken like this. So direction of I3, here you can see I have made like this, right? So direction of I3 is this, right? So this I2 and I3 are in opposite direction. Okay, so therefore IN should be I2 minus I3. That is what we have got. Once I have got IN, and this RN, this equivalent resistance in this circuit, will be equal to that RTH that we have already got in Thevenin's theorem. This is this RTH, this equivalent circuit, equivalent resistance is already calculated here, right? So that will be the RN here in this case. And once you have got RN and IN, then you can you can draw this Norton's equivalent circuit, right? So this is RN, there should be ohm. So this is question number E. Now let's move on to next question, 4D. 4F. This is question number 4F1. What do you mean by resonance in LCR circuit? So this is the definition, resonance in LCR circuit, right? So I'm not gonna explain one by one word. Okay, derive the expression for resonant frequency. Let me show you the derivation. Also draw resonance curve, and let me show the resonance curves as well. Now you see, this is the LCR circuit. So here you see, just wait. So resonance takes place when inductive reactance is equal to capacitive reactance, right? So inductive reactance is equal to this, and this is the capacitive reactance, right? So here you can see, from here what we can write: omega square 1 by LC. So omega will be equal to 1 by root over LC, right? So you can write, we know that F is equal to omega by 2 pi, right? So if you put this, if you use this value, then what you will get, F is equal to, so just simply write, let me show something here. So here you can see, this omega can be replaced by 2 pi f, right? 2 pi f 1 by root over LC. So here f will be equal to 1 by 2 pi into root over LC, right? So this is resonant frequency, right? So hope you have understood this. So let me write the equal sign here. Okay, so now let me show you the resonant curve. Now at resonant frequency, that is 1 by 2 pi root over LC, so the current is maximum. So that's why here the current is maximum. Let me write I max here. So current is maximum. So you can see, let me write current I max. So if you go either side of this point, from this point, then this graph should be like this. Current on either side will be decreasing, right? This is the graph for resonant frequency in LCR circuit. So hope you have understood this. So I will solve the next questions in remaining questions in the next videos. Okay, so hope you like this video. Like, share and subscribe, and inspire me to create new contents for you. So thank you for watching, and see you in the next video.